The introduction of new water sports has often been criticized by opponents who prefer the status quo. Water skiing and tubing were criticized as disrupting silent sports and fishing. There are similar complaints about personal watercraft. But recently, conservation groups have villainized wake boats and wake surfing, advocating for severe restrictions and bans. The basis for these restrictions is often focused on shoreline erosion, damage to lake beds, spread of invasive species, and safety. These criticisms are gross exaggerations justified using incomplete information, often dismissing or omitting critical contrary data. Wake surfing is growing in popularity because it expands access to recreational boating. It is less strenuous than other water sports, allowing older and physically challenged individuals to enjoy Wisconsin waters. Wake surfing is done at slow speeds, typically 11 miles an hour, making falls less violent, does not require being towed, and feet are not constrained, reducing the risk of injury. For example, Chris Marion was a firefighter and a paramedic who was an avid water skier. He was part of the chain skimmer demonstration team who was tragically paralyzed in a barefooting accident. While he has regained some mobility, he can no longer water ski, but wake surfing allows him to continue to enjoy Wisconsin lakes. Groups working to ban wakeboats are attempting to take away access to Wisconsin lakes for older and physically challenged individuals. This is in direct conflict with Wisconsin's public trust doctrine.
Large waves can be produced by many sources. Any large and heavy boat, like bow riders and cruisers, will produce large waves. Driving in repetitive patterns, such as tubing, or multiple water ski boats on the same body of water can result in constructive interference, also producing large wakes. Wake boats have been inappropriately singled out as a unique threat to Wisconsin waters. Any boat driving too close to shore or in an inappropriate manner can create a hazard. Proponents of bans on the use of ballast and wake-shaping devices are silent concerning other sources of large waves, like Chris-Craft cruisers and other heavy watercraft. Thus, they are drawing a capricious distinction. Concerns about wakes must be treated for all watercraft equally using quantitative data, not anecdotes. It has been erroneously claimed that shore erosion is caused by wake boats. Shore erosion is a legitimate concern. It is a complex phenomenon that depends on many things. The largest cause of shore erosion in lakes are overdevelopment and natural factors. In spring, lake levels are at their highest. As the winter ice breaks up, strong spring winds drive it to shore, disturbing soil, rocks, and even vegetation. Storm winds drive water throughout the year, creating powerful waves that also contribute to erosion. Critics of wakeboats say large waves they create can destabilize the shore and exacerbate erosion. However, it's important to note that any boat, not just wakeboats, creating a large wake too close to shore has the potential to damage the shoreline. The key question is what constitutes too close. Boat wakes have been studied for over 40 years. There are many experimental studies examining the waves from boats. Some of the most comprehensive work has been done by the Australian Maritime College. They have a database characterizing over 6,000 watercraft. Gregor McFarland has been studying this for over 30 years and has the most comprehensive set of data. As shown in this graph, the maximum wave height for all watercraft decay with distance. Initially, there's a large wave at the back of the boat, but due to the physics of these divergent waves, it breaks up into multiple waves with lower amplitude. McFarland shows data for 4 wake surfing boats, a fishing boat, a ski boat specifically designed not to produce a wake, and then varied the operating speeds. The wake boat speeds were varied from 10 to 12 miles an hour. The highest wave heights occur at the slowest speeds, which are not typical of wake surfing. He also included the data from Gowdy and Gerard in 2015, the green X's. Also added to the graph is data from the St. Anthony Falls study, Rupert, and Terra Vigilis. There are several key takeaways from this data. There is a general agreement in wave height, although the St. Anthony Falls studies show outliers at the high end of the curves. These will be discussed later. A fishing boat can produce waves as large as a wake boat. There is no basis to single out a wake boat from other fishing boats or heavy watercraft. Ballast makes no difference after 50 to 100 feet. The wave heights are equivalent. Gowdy has added 1,500 extra pounds of ballast beyond the factory settings, which is why his data shows slightly larger waves.
Even the St. Anthony Falls study, which is often quoted, shows there's no difference in wave height after 100 feet whether a boat has or does not have ballast. This is important since many ordinances inappropriately target ballast.
The anti-wakeboating groups say water skiing and other boats are okay, but attack wakeboats. This data shows that a wakeboat at 200 feet from the shore generates a similar wave to that from a Malibu response at its maximum wave conditions. 200 feet from the boat, most wakeboats produce 8 to 10-inch waves, the same height as a Malibu response. There is no legitimate rationale to claim wakeboats need to be more than 200 feet from shore if you're willing to accept water ski boats and fishing boats at 100 feet.
Going back to the data, the area in green shows the wave height of the Malibu ski boat in the St. Anthony Falls study and the fishing boat in McFarland's study at 100 feet. Wake boats at 200 feet produce waves equivalent or smaller. The data clearly shows restrictions on wake boats of more than 200 feet are arbitrary and capricious and not supported by experimental data. Furthermore, wake surfing produces an asymmetrical wave, with the surf wave being larger on one side than the other. Most boat captains send the larger wave away from shore, so this is a very conservative statement.
Many people use the 2022 Marr et al. Study from the Minnesota St. Anthony Falls lab to justify wakeboat bans or extreme setback distances. This study has many serious issues and is the least important of all the prior work. The 2022 study exhibits an unacceptably large variation in their actual data. For instance, at 200 feet, they report wave heights for a Malibu MXZ of 9 inches and 18 inches, a 100% variation. In experiments of this type, anything over 20% is cause to rethink the experimental design. This study's variation is 5x that which is considered acceptable. The study's data analysis is also fundamentally flawed, presenting a significant issue for interpretation. For wave packets similar to those analyzed by other researchers, this study reports a total wave energy that is 3 to 8 times higher than expected. Specifically, at the back of an MXZ, they calculated a wave energy of 16,000 joules per meter, whereas previous studies have found values between 1,800 and 2,400. When questioned about this substantial discrepancy, the authors merely stated they were busy, highlighting a lack of accountability. This is critical because their energy calculations underpin the extreme setbacks they propose. The combination of poor data quality and calculation errors renders any decision based on this study irresponsible. This study did not follow standard protocols for scientific work. It did not cite or discuss prior studies, such as McFarland or Gowdy, etc. The authors claim it was peer-reviewed, but they did not follow the peer review protocol. They sent it to 2 extremely critical reviewers, but they were never given a chance to comment on any of the changes or agree if it was suitable for publication. In an attempt to overcome the massive data variation, the authors fit a line that uses a regression for calculations. This masks the error in their data. This image demonstrates the problems with smooth data. On average, the ducks are dead. But as can be seen, numerical manipulation hides the real story. Averaging to reduce noise is okay when you have random variation, but when you have systematic noise, as in the St. Anthony Falls study, where you have a consistent offset between the 2 types of sensors, averaging is not appropriate or allowed. While wave height is easy to understand, literature shows it's inadequate to describe erosion potential. The wave period is even more critical. Wave period combined with wave height are used to calculate the maximum wave energy. Looking at 2 waves, intuition might suggest a 12-inch tall wave is more energetic than an 8-inch wave, but due to the difference in the period, these actually have the same wave energy. Greg Cox completed his PhD thesis under McFarland and has done extensive work on shore erosion, which was a concern when high-speed ferries started service in Australian rivers. He has shown that shorelines are more resilient to wave height than wave period. In other words, the dynamic stability of a shoreline is more able to accommodate a taller wave than it is a wave with a longer period. The form of the energy matters, and you have to consider the total energy of the wave and the period of the wave. Wave energy, which includes contributions from height and period, decays rapidly with distance from the boat. Gowdy and others have shown that while there is a large wave at the boat, after 200 feet, 70% of the energy has decayed to levels below that produced by a 20-mile-an-hour wind blowing over a mile of water. McFarland calculated the maximum wave energy for many watercraft. It shows the same trends. Maximum wave energy for various boats decays rapidly with distance. It also confirms that after 200 feet, the wave energy from a wake boat is below the max wave energy of a ski boat produced at 100 feet, further validating there's no legitimate basis to accept ski boats and not accept watercraft such as wake boats 200 feet from shore. Another criteria to examine any potential impact of boat wakes on a shore is to compare it to what is experienced naturally. These two graphs show the change in a wave packet versus what is typical of a 20-mile-an-hour wind over 1 mile. At 200 feet, the height and the periods are similar. Shorelines adapt to their natural environment. Maintaining the distance of 200 feet from shore ensures that the wake energy from a wake boat decays sufficiently so that the waves do not differ significantly from natural conditions and do not contribute to shoreline erosion. At this distance, wake boat waves are 8 to 10 inches high with a period of 2 seconds, similar to waves produced by a 20-mile-an-hour wind, which are about 8 inches tall with a 1.6 to 2 second period. What is very different is the total amount of energy impacting the shore between a wind and a boat wake. Boat wakes progress in packets that last 30 to 60 seconds, but wind waves are constant. For a 20-mile-an-hour wind, a 7 to 8 inch wave hits the shore every 2 seconds. On larger lakes, these waves can be 12 inches with 2.6 second periods containing significant amount of energy. For a wake boat 200 feet from shore to present the same amount of energy as a 20-mile-an-hour wind, it would have to pass the shore in the exact same spot every minute, which is never the case.
Extended periods of average daily winds of 20 miles per hour are common in northern Wisconsin, especially in the spring when lake levels are at their highest. The historical data from the Eagle River Airport reports in April and May, more than 15% of the days had average winds over 20 miles per hour, and in April, approximately 9% had winds in excess of 25 miles per hour, with gusts up to 40 miles per hour. This wind energy will produce energetic waves larger than any boat will produce 200 feet from shore. On larger lakes, the wind waves are even more energetic and can be up to 12 or 14 inches tall.
The data from Rhinelander shows the same trends. There is a large amount of days with significant winds producing high energy waves that cause erosion much more than any boat will do. Many studies conducted over years have shown that boat wakes produce a minor amount of energy experienced by a shoreline. Even the St. Anthony Falls lab, whose report is used to justify shoreline erosion arguments, wrote an earlier report that states shoreline erosion is mainly by wind-generated wave energy. Both simply do not add to shoreline erosion. Comparing wind and boat wakes is only appropriate when the waves have similar heights and periods, which is the case in Wisconsin. Cox and McFarland caution that the form of energy is important, meaning period versus height. They say comparison of annualized boat wave and energy and wind wave energy are meaningless for comparing the impacts of different wave regimes. The key phrase is the last 3 words, different wave regimes. In Wisconsin, boats of 20 to 23 foot length will produce periods of 2 seconds, which is similar to wind waves. So it is a completely valid comparison. Wisconsin is not the only state looking at boating regulations. We can see precedents in the South where Tennessee, Alabama, Georgia, and South Carolina have boating seasons that are 12 months long. All have adopted 200 feet setbacks. Why would Wisconsin believe it requires something different than these states that have much more boat traffic? A second argument against wakeboats are claims that the prop wash scour the lake bottom. Computational studies have examined the potential impact of propeller wash on lake beds with conflicting conclusions. These studies estimate water flow and velocities at various depths and then speculate on the impact. All these studies require multiple assumptions and the conclusions need validation. One experimental study actually measured velocities and found that they could get 0.2 miles per hour water velocity at 10 feet. The authors speculated this would cause erosion, but the actual diver found that there was no impact on the sediment. The issue with all these studies is they fail to measure the primary assertion that prop wash resuspends lake sediment. The Indiana National Academy of Science published a definitive study measuring actual lakebed disturbances in 2022. This experimental work examines sediment resuspension from several different boat types, including ballasted wake boats. The results show that all boats can disturb lakebeds in 3 to 5 feet of water, but once wake boats operate at a depth of 10 feet or greater, lake sediment does not resuspend. This conclusive study demonstrates that the claims of wake boat hurting lakebeds in more than 10 feet of water is absolutely false. Further proof of this comes from the Wisconsin database on lake water quality. It does not support claims that wake boats increase turbidity or algae bloom. Wisconsin water quality is excellent and shows no deterioration in lake clarity since wake boats were introduced. The spread of invasive species is a significant concern for all types of watercraft, but wake boats are not a unique problem. The main issue is that the internal ballast tanks are difficult to inspect and could potentially contribute to the spread of invasive species. However, all watercraft and trailers retain water, thus posing a risk. It's arbitrary and capricious to single out wake boats. Modern wake boats are designed to expel nearly all of their ballast water, retaining only 0.1% of their ballast, approximately 2 quarts. In contrast, stern drive, inboard-outboard, retain twice as much water, about 4 quarts in their internal cooling channels. These systems also cannot be inspected. Additionally, unlike fishing boats and other boats that frequently move between lakes, most wake boats use primary on their owner's lake, which reduces the risk of spreading invasive species. A study in Minnesota found that the highest concentration of zebra mussels was in a stern drive rather than a wake boat. Furthermore, milfoil and often other invasive species are found in shallow water, and it's not commonly ingested in a wake boat as they typically only operate in deep water. While AIS is a concern, efforts should be directed towards improving sanitation and certification practices for all watercraft rather than trying to focus myopically on wake boats. A final complaint is that wake boats are not safe. The U.S. Coast Guard has approved wake boats as safe. Wake boats have safely operated in Wisconsin for over 10 years. There's no records of boating accidents or citations for wake boats, yet there are many reports for fishing boats, personal watercraft, and pontoon boats. The claims that wake boats present a unique safety risk is unfounded. There is no legitimate argument to restrict wake boats more than 200 feet from shore or ban their operation. Regulations attempting to do so are capricious and deprive access to Wisconsin waters. Wake boats must be treated the same as any other watercraft. All relevant data must be considered and none excluded. Wake boats at 200 feet from shore is equivalent to a ski boat at 100 feet and wind-driven waves. They do not present a risk for shore erosion. Prop wash does not resuspend sediment in greater than 10 feet of water. AIS risk is present for all watercraft. Stern drive retain more water than a ballast system. The Coast Guard has certified and identified that wake boats are safe. Any attempts to restrict their operation are unjustified.